On the afternoon of May 25th, 1979, at the beginning of Memorial Day weekend, American Airlines Flight 191 crashed near Chicago's O'Hare International Airport, killing all 258 passengers and 13 crew members aboard, as well as 2 people on the ground. A total of 273 fatalities. In 31 horrifying seconds, America's deadliest aviation disaster unfolded as witnesses watched a massive engine tear away from the wing during takeoff, sending the DC-10 rolling inverted before plunging into an open field. The crash would expose a deadly combination of flawed maintenance procedures, design vulnerabilities, and a cascade of system failures that left experienced pilots powerless to save their own aircraft. But before we get into this video, if you guys want to see more disasters and airplane crash investigations, be sure to like and subscribe. And with that said, let's get straight into the video. It was a bright, clear day in Chicago. Perfect flying weather. On the 25th of May 1979, 258 passengers boarded American Airlines Flight 191 to Los Angeles, a McDonnell Douglas DC-10, and the cabin was filled with holiday travelers, families heading to Southern California for a vacation, business executives attending a publisher's conference, and others simply looking forward to a long weekend. Among the passengers were entire families excited about their trips. The mood was festive, typical of a holiday weekend departure. Nobody aboard could have imagined that their flight would barely make it past the end of the runway. The aircraft operating as Flight 191 was the McDonnell Douglas DC-10-10. The DC-10 was a wide-body trijet, meaning it had 3 engines, one under each wing and one mounted on the tail. This particular aircraft had been in service since 1972 and had accumulated approximately 20,000 flight hours. In command was 53-year-old Captain Walter Lux, a veteran pilot who was type-rated on at least 8 different airliners and who had more than 22,500 flight hours. Captain Lux was a highly experienced and well-respected pilot within American Airlines. Assisting him in the cockpit was 49-year-old First Officer James Stillard and 56-year-old Flight Engineer Alfred Udovich, who together possessed an additional 24,000 flight hours. This was an exceptionally experienced flight crew, veterans who had handled countless emergencies and challenging situations throughout their careers. Their combined experience totaled over 46,000 flight hours. Under normal circumstances, this level of expertise would be more than sufficient to handle any emergency. But the situation they were about to face was anything but normal. At approximately 3 p.m. Central Daylight Time, Flight 191 was cleared for takeoff from runway 32 right. The DC-10 began its takeoff roll down the 10,000-foot runway, accelerating normally. Everything appeared routine. The 3 Pratt & Whitney engines roared at full power as the aircraft gained speed. Halfway down the runway at 5,000 feet, the plane reached the 175 miles per hour needed to take off. As the DC-10 approached rotation speed, the point where the pilot pulls back on the controls to lift the nose, something catastrophic occurred. As the McDonnell Douglas DC-10 was taking off on the runway, its left engine detached from its wing, causing a loss of control. The massive engine and pylon assembly, weighing approximately 9,000 pounds, separated from the left wing, flipped over and over the wing's leading edge and crashed onto the runway behind the accelerating aircraft. On the cockpit voice recorder, one of the pilots was heard saying "damn" after a loud thunk, the sound of the engine separation. It was the last word captured before the aircraft's electrical systems failed and the recorder stopped functioning. What happened next was captured in a series of remarkable photographs taken by Michael Laughlin, a 24-year-old student pilot who was on a layover at O'Hare. Laughlin had his camera with him and was photographing aircraft when Flight 191 began its takeoff roll. His photographs would become crucial evidence in the investigation. The dramatic images showing the left engine missing from the wing, white vapor trails of fuels and hydraulic fluid streaming from the damaged wing, and the aircraft in its final moments of flight. Unknown to the pilots, the engine separation had triggered a cascade of failures that made their situation virtually unrecoverable. When the engine tore away, it took away with it approximately 3 feet of the wing's leading edge. More critically, it severed hydraulic lines that control the leading edge slats on the left wing. The leading edge slats are movable panels on the front of the wing that extend during takeoff and landing to increase the wing's ability to generate lift at lower speeds. On the DC-10, these slats were held in the extended position solely by hydraulic pressure. There was no mechanical lock to keep them extended if hydraulic pressure was lost. And as mentioned earlier, the engine separation severed the hydraulic fluid lines that controlled the leading edge slats on the left wing and locked them in place, causing the outboard slats to retract under air load. With no hydraulic pressure to hold them extended, aerodynamic forces pushed the left wing's outboard slats back into the retracted position. This created an asymmetric configuration that would prove fatal. The right wing still had its slats fully extended, while the left wing's outboard slats had retracted. This asymmetry had two devastating effects. First, the left wing was now producing significantly less lift than the right wing. Second, and more critically, the retraction of the slats raised the stall speed of the left wing. The pilots did exactly what they were trained to do. When an engine fails during takeoff after reaching decision speed, the correct procedure is to continue the takeoff and climb to a safe altitude using the remaining engines. The DC-10 was designed to fly safely on two engines. American Airlines procedures specified that following an engine failure, pilots should maintain the aircraft's pitch attitude as directed by the flight director, an instrument that provides guidance for optimal climb performance, and accelerate to V2 speed, the takeoff safety speed that ensures adequate climb performance with one engine inoperative. The experienced pilots, Captain Walter and First Officer James, knew it was too late to abort the takeoff, but they immediately attempted the correct procedure for climbing on two engines. First Officer Dillard, who was flying the aircraft, followed the flight director guidance and raised the nose. The aircraft began to decelerate from its current speed toward the prescribed V2 speed of 153 knots. But the pilots were flying blind in a critical way. They had no idea that the left wing slats had retracted, and therefore no idea that the stall speed on their left wing had increased. But why didn't the pilots know about the slat retraction? The answer lies in a cascade of electrical failures triggered by the engine separation. The DC-10 incorporates two warning devices that might have alerted the pilots to the impending stall: the slat disagreement warning light, which should have illuminated after the uncommanded retraction of the slats, and the stick shaker on the captain's control column, which activates close to the stall speed. Both of these warning devices were powered by an electric generator driven by the number 1 engine, and both became inoperative after the loss of that engine. When the engine separated, it caused electrical short circuits that tripped circuit breakers and isolated the electrical bus powered by the number 1 engine. This bus supplied power to numerous critical systems. All of these systems went dark the instant the engine separated. The first officer's control column was not equipped with a stick shaker. McDonnell Douglas offered the device as an option for the first officer, but American Airlines chose not to have it installed on its DC-10 fleet. If American Airlines had purchased the optional second stick shaker for the first officer's control column, powered by a different electrical bus, the crew might have received the warning of the impending stall. The slat position indicators in the cockpit went blank. The slat disagreement warning, which would have alerted them that the left and right wing slats were in different positions, never activated. The pilots had no way to know that by following standard procedures and decelerating to V2, they were descending directly into an aerodynamic trap. Flight 191 was airborne for only 31 seconds. After achieving its highest altitude of 325 feet, the airliner pitched down with its left wing struck the ground. At 325 feet above ground level, the left wing entered a full aerodynamic stall with the right wing still generating lift and the left wing producing almost none. The aircraft began rolling rapidly to the left. The pilots applied full right aileron and right rudder, fighting desperately to control the roll, but the aerodynamic forces were overwhelming. The aircraft crashed around 4,600 feet from the end of the runway. The impact occurred in an open field adjacent to a mobile park home just northwest of the airport. The impact and subsequent explosion were catastrophic. The aircraft, still carrying most of its fuel load for the cross-country flight, disintegrated on impact. A massive fireball erupted as thousands of gallons of jet fuel ignited. The explosion destroyed an old aircraft hangar, several automobiles, and a mobile home. 2 people on the ground were killed by the falling debris. Firefighters who arrived at the scene within a couple of minutes of the disaster recalled that it was total devastation. The intensity of the fire was so extreme that the firefighters initially could not approach the wreckage. The heat was so overwhelming and the smoke could be seen for miles. All 271 people aboard were killed, along with 2 more souls on the ground. It remains to this day the deadliest aircraft accident on US soil. The disintegration was so complete that little useful information could be gleaned from the examining wreckage itself. Bodies were burned beyond recognition, requiring forensic dentists to identify victims. Emergency workers marked human remains with numbered flags as they carefully searched for the still smoldering debris. The National Transportation Safety Board, or NTSB, dispatched a GO team to the crash site that evening. The most obvious piece of evidence was still found on the runway, the number 1 left engine that separated from the doomed DC-10. The engine rolled over the top of the left wing during takeoff and was found next to the departure runway. This immediately told investigators that the engine separation had occurred, but the critical question was why. Engine separations are extraordinarily rare events. Modern commercial aircraft are designed so that even if an engine fails catastrophically, it should remain attached to the wing. So something had clearly gone very wrong with the structure that connected the engine to the wing. The investigation revealed that the pylon had been damaged during maintenance performed approximately 2 months before the accident on March 30, 1979. The damage occurred when American Airlines maintenance personnel removed and reinstalled the left engine and pylon assembly. McDonnell Douglas, the aircraft manufacturer, had published specific procedures for removing and replacing engines. The proper method was this 2-step process. You first remove the engine from the pylon, then remove the pylon from the wing. Each step was to be done separately, using specialized equipment to support the components. However, this procedure was time-consuming and labor-intensive. To save time and money, American Airlines, along with some other carriers, had developed an alternate procedure, removing the engine and pylon as a single unit using a large forklift to support the combined weight. In 2 prior cases on Continental DC-10 airplanes in December 1978 and February 1979, the engine/pylon assembly reinstallation had resulted in damage nearly identical to that occurred on the accident airplane. In both events at Continental, the sound of the flange fracturing was heard by the maintenance personnel. These warnings were not reported to McDonnell Douglas or the FAA. The forklift supporting the engine pylon assembly remained in place overnight between shifts, and investigators suspected that the hydraulic pressure in the forklift may have bled off, causing the forks to move slightly. This small movement, combined with improper procedure, caused the forward bulkhead to bend upwards and contact the wing structure above it. The contact created a small fracture on the upper flange of the pylon's aft bulkhead. The fracture was only about 10 inches long, but it was located at a critical structural point. The damage was not visible during routine inspections because it was hidden behind the engine. Over the next following 2 months and about 1,200 flight cycles, the crack slowly propagated through the structure due to the constant stresses of flight. Each takeoff, each landing, each cycle of pressurization added stress to the weakened component. On May 25, 1979, during Flight 191's takeoff rotation, the crack finally caused complete structural failure. The aft bulkhead separated, allowing the entire engine and pylon to pivot upwards and tear away from the wing. Critically, the NTSB concluded that these 2 events at Continental should have been viewed as an indication that the alternate installation procedure was inappropriate. But because they weren't reported beyond Continental Airlines, the industry never learned of the danger. Simulator tests conducted after the accident proved conclusively that the crew had no reasonable opportunity to save the aircraft. Experienced test pilots, knowing in advance what would happen and given multiple attempts, could not prevent the crash when replicating the conditions faced by Flight 191. When pilots followed American Airlines engine failure procedure and decelerated to V2 speed, they lost control every time. On June 6, 1979, 2 weeks after the accident, the FAA suspended the type certification for the DC-10, thereby grounding all DC-10s under its jurisdiction. It was an unprecedented action, the first time the FAA had ever grounded an entire aircraft type. The grounding included an air regulation that prevented foreign DC-10s from flying into US airspace. The grounding was prompted by the discovery that several other airlines had also been using the unapproved forklift procedure, and inspections revealed cracks in the other DC-10 pylons. American Airlines Flight 191 remains the deadliest aviation accident in United States history. The crash demonstrated how seemingly minor maintenance errors can have catastrophic consequences, how cost-cutting shortcuts can prove fatal, and how a cascade of failures can overwhelm even the most experienced crews. The pilots of Flight 191 did everything right according to their training and procedures. They followed the prescribed actions for an engine failure during takeoff. But they were trapped in an impossible situation. Following proper procedures led them directly into an uncontrollable aerodynamic condition they couldn't see, couldn't detect, and couldn't recover from. The tragedy exposed fundamental vulnerabilities in the DC-10's design, particularly the lack of mechanical locks for the leading edge slats and the single point of failure in the warning systems. It revealed how inadequate regulatory oversight allowed dangerous maintenance procedures to spread across multiple airlines. It showed how poor communication prevented warning signs from being shared and acted upon. The safety improvements that emerged from the disaster, stricter adherence to approved maintenance procedures, better regulatory oversight, improved aircraft design standards, and mandatory reporting systems have made aviation significantly safer. These measures honor the memory of all of those who died on that day and prevent similar tragedies in the decade since. But today, the bricks bearing 273 names stand at the memorials, a permanent reminder that aviation safety is never an accident. It is achieved through rigorous procedures, constant vigilance, and the hard lessons learned from past tragedies. And that's all for today's video. I hope you guys enjoyed. This is a long one and a bit more complicated than I normally make them. I don't think I'll be making them as detailed in the future because I feel like this gets a lot of lost and it's pretty hard to edit to show all of the stuff that I'm talking about and researching. So that's there. However, I hope you guys enjoyed.